In last lecture, we talked about the probability, or you can say usage of linear regression in terms of probability, or you can say log function. But important of all in different scenario, that how we can get our finalized result is kind of a convergence criteria. Convergence means we are getting some stable, or you can say some target result. For this, we are dealing with the convex function. Particularly, whatever the theme behind the convex function is how we can decide between two or multiple things, okay? Because with the help of deep learning, we need to make a solid decision or some kind of a useful decision. So, and initially, with the simplest model, we say our decision can be made with the help of linear model. Sometimes we also deal with the non-linear model. And in this linear model, we know if we are dealing the two-dimension things, simple line is enough. Usually we say linear regression. But in case of more than two dimension or m dimensions, then we need a plane or hyperplane. Hyperplane, too many planes.
Yes.
If we made a question in our mind, of course, these are the two things. Two dimension mean does not that only the kind of this board, okay, that's the horizontal axis, y-axis. Even the two we need to differentiate the two different things. Mean we are talking about the two-dimension things. Are you getting the concept of dimensions now?
Yes.
Yeah, the dimensions does not mean only x-axis and y-axis. Dimensions tell us the different scenario, okay? So there are two possible scenarios. One is the green one is the red one, okay? So plus or negative sign. We need to, this is the two-dimensional things. And of course, it's very simple. We can separate it with the help of a line. But in all this case, we are talking about the loss function. Loss function is what basically we compute the different distance. Distance is also categorized as a difference. Between the current output of the algorithm or current output of the situation and the expected output. Current output means benchmark, standard thing, okay? And the expected, how we are getting with the help of experiment, with our observation. This is the thing, okay? And the difference between two things, of course, there is some kind of a, if we are considering the difference of two things, we are getting some kind of output, and this output is known as a loss function, loss value basically. And its method can be evaluated with the help of convexity. Let me explain the loss, okay? For example, we are standing at somewhere peak, or we are reaching to somewhere there, then of course the difference. And okay, for each step there is some kind of a difference. And this difference can be measured with the help of change. Of course, at each step, we are making some kind of a change with respect to the previous one. And this change is measured with the help of derivative, or technically you can say differentiable. And this derivative is measuring the change for a particular, okay, for making a wonderful decision in terms of this continuous pattern, okay? So, for example, we are growing up from our childhood in a continuous pattern. It is, we could not say that somewhere we are dead, okay? We were dead for 2 years, from 2009 to 10 we became dead and then we start our, okay, growing, we become young like, no, continues. From our childhood to our adulthood, we are growing up in a continuous fashion, okay? So change is observed in this kind of a thing, in the continuous pattern, indication that whatever this minimization concept is technically similar kind of a maximization. What's the theme of this? For example, from our childhood, we are reaching to the adulthood or some kind our youth. Then from youth to our, okay, you can say that in the our old age, again our health is decaying. Everything is following this kind of thing. Then maximum, minimum, it is some kind of a, okay, from youth to our old age, you can say it is again from the minimum to maximum or the maximum to minimum. So reaching to some kind of a target, and this target is attained with the help of derivative, change, stepwise change, differentiating.
So total change called loss function?
No, total change, yeah, there are two things, okay? If you are talking about the total change, then it is known as a global loss function. Global loss function. If you are talking about the small change, okay, from 1 year to 2 year, okay, then it is a local change. Mean if you want to make some kind of a product, then overall change, net change, resultant change, final change is kind of a global. Small variation, small chunks, you can say it's a local change. So somewhere in textbook you will see, whenever you talk about the loss function, you will notice about some kind of a convex function. Convex function is coming, convex lens, you studied about the convex lens, concave lens. Basically this is the point, okay, some kind of a target point somewhere, for simplicity purpose, they are dealing with this. So from one end to, okay, this at this bottom line, it is reaching some kind of a point, or somewhere they are also, this is also kind of a convex, okay. So loss function is also the categorized in terms of convex function. Basically, what is this basically? This is some kind of a line, okay, line. Basically, if we are talking about some change at this point, this is what? At this only single one point, it is basically derivative, differentiable. Okay, differentiable of what? dy over dx. Once your delta x, big change, approaches to 0, small value. So we are considering only the one value, one point. Then it is giving you the change at an instant. For example, you are observing the speed of a car at particular point at instant, derivative. Okay, so this is basically gradient descent. We are talking about the gradient descent in a similar fashion. So for observing the minimum point, or you can say you want to reach, okay, in this case at this point you are standing somewhere at the top of the mountain, then with the blindfold, how will you reach? Grade, okay, slow steps, small steps. And these small steps can be categorized with the help of derivative. Change, small change. But this change should not be very small, otherwise you will take ages to reach at the bottom. Okay? But again, you should not consider a big change. You can fall down. Okay? So the situation is this: amicable change, sensible change. How this sensible change can be noticed? Okay, to reach at the minimum or at the target point. So again, I told you the minimum and maximum is kind of a replica of one another. You should not worry about this. And this gradient, you need to consider a partial derivative. You need to consider only one or particular parameter. For example, you are talking about the money matters. Okay, you don't consider about your health, you don't consider about anything else food. You say that I need to earn money by hook and crook. You are ignoring all the rules and regulations. In other case, you are considering only about the health. You are not considering about the time. You are paying attention to make your health good. So the partial derivative. Partially you are considering one particular parameter. So I will explain this. Okay, so these are the basically small steps. You are reaching at this point, and somewhere you can observe this kind of a picture in your books. Your advanced deep learning material, you will see this kind of a step, that this is representing some kind of a convex or cost function. Big change, then small change reach to the center. Similarly, you can also notice basically this is kind of a circular pattern. Okay, it should not be a kind of ellipse, it should be a circle. Then you reach to the center point. In gradient descent, this is the starting point, okay, weight parameter. This is, we are talking about, in case of house, we are saying the quality or price of the house, of course, it should be a house, initial weight parameter. So this is the starting point, then that fulfills the basic criteria, it's one kitchen, one room or one bathroom, whatsoever the basic criteria of the house. Then you should start to figure out its price or some kind of a thing with the help of pick a dimension, then other things. Too many parameters can be involved for making your house a dream house. So with the help of gradient descent, you can notice or you can observe the change. And again, I told you that the big step, kind of a dangerous thing. And in this case, you will, the term, a moment ago, I used the term convergence. Here, convergence means kind of a stability. You can achieve your target. You can reach to your target. But in this case, if your steps are not amicable, not sensible, not moderate, then the system will diverge. Not stable. You will not reach your point in a safe way. Our system will be collapsed. Many possibilities are there. So for this, I would like to explain. Yeah, of course, your gradient is not kind of a consistent, some kind of inconsistent. Sometimes you are considering a big change, somewhere small change. So the system will ultimately become diverges. So important thing in all this loss function or convex function, what is the convergence? If you will not fulfill the criteria of convergence, then system will diverge. Divergence means unstability. Unstability is the thing, very dangerous thing in advanced deep learning. So let me explain this concept with the help of one example. For example, you have certain blocks. With the help of blocks, you want to construct some kind of a bridge. For example, the nature of a bridge is this. If there is some kind of a metropolitan city, and another side there is a bridge where traffic is moving, beneath the bridge there is a fields, you can say this is the open area. mayor of the city or Wavda people want to pass some kind of a power transmission line and somewhere there, but the problem is this: there is no open space for passing the power transmission line. However, there is a lake, okay, you can say a water canal. This is the water canal. However, you do not allow to touch the water. But you want to pass the transmission line, okay? You should not touch to this metropolitan city. You do not allow to touch this bridge. You do not allow to touch this water. How you can place your transmission poles?
diverge the
Yeah, there are many ways. I don't want to put you in trouble, but for simplicity purpose, you can place your base of the tower somewhere under the bridge. Somewhere under the bridge, and such that for example, this way, this is not a green area, okay, it's not side, you cannot touch the open area, but you can utilize the space under the beneath the bridge. So, and this block and this such a way, for example, you starting from under the bridge like this. Whatsoever, this is the just beneath the bridge, and your top is the middle of the this water canal, but it is above the canal. It will not touch the canal. Are you getting my point?
stairs, like a stair.
Yeah, like a stairs, and this is okay exactly just beneath the bridge, or you can say, in other words, your top layer should away from the bottom layer. Bottom block, this one is your top block, at least it should,
Touch.
okay, one edge of the top edge of the block should be exactly at least, okay, bottom block, okay, first block, or you can say just, it should step away from the, just away from the bridge. Are you getting my point?
Yes.
So, of course, it should be, it should follow the rule of convergence. Or in other words, you can say it should follow the some kind of a stability. So I brought these blocks for you. You need to construct a bridge. I am saying that last top block should away from the
First
bottom
block.
one.
नहीं सपोर्ट नहीं देनी
Yes, you don't need, you should not provide any support to it.
Support se dá se que mobili step de fazer que se dá dentro de pai. Simple shit.
स्कीम नहीं किया मैं काम देता हूँ चेक पे
आज ऐसे सालों लग जाएंगे
थोड़ा थोड़ा बढ़ाएंगे ना उससे तुमने कंज्यूम कर लिया
No,
ऐसा नहीं होगा
और आपने जो सीधा ब्लॉक नहीं तो ब्रिज के नीचे ब्रिज नहीं वो तो ब्रिज को टच कर रहे हैं ना
आदिल को कर
दूर है ना
यही की साइड से करना है, दूसरी साइड से नहीं
नहीं
होगा?
No, only one side. You got the point, that's only one side. Bridge is on one side, you need to start from the one side and you need almost up to the middle somewhere.
इधर जो नहीं होगा। तो किसी भी अरेंजमेंट में कर सकते हैं।
Yes.
ऐसा भी कर सकते हैं। बैलेंस करने के लिए।
इधर खोल ले भाई।
इधर नहीं आपको किधर मुश्किल गिरेंगे बजाय उसके
Like space, small steps, doesn't mean
सपोर्ट नहीं
Oh, okay, sit down, sit down. Thank you so much, please. That's okay. Okay, let's see some mathematics, okay? There is nothing, there is no problem in life which can't be solved with the help of mathematics. You need a mathematics, okay? For example, suppose this kind of a block, just suppose the center of mass of this block, okay, somewhere, suppose this one is a block. Center, if I am talking about the center of mass at the edge of block, is there any mass weight? No. At this edge, at this point, of course, C0, okay? Are you getting my point? At the edge, there is no weight, no center of mass, at the edge, okay? But if you are considering mid of it, suppose it's 2, then at the mid it becomes 1 because 1 is okay, both sides 1. So at this point C1 equivalent to 1. Then now, okay, you need to divide this one. Of course, I'm considering this one. At this position, you need to consider too many blocks, or suppose there are n blocks, n number of blocks. Moment you can notice there are n number of blocks, too many blocks, but one block should be on the ground. Okay, this is the firm block, you know. One block, this one block must be on a ground. Rest of the blocks in somewhere above the ground, but one block is on the ground. So total number of blocks are
n -1
n plus 1. Until here it is clear? Good. Okay, so if you are talking about the n plus number of block, or you can say center of mass for n, this one you want to know. Of course, it is equivalent to the total these. If you are talking about these, then center of mass of this is Cn plus 1 block. And then, okay, you are talking about the n total, okay, if I am talking about these blocks,